Welcome to 47th lecture in the course of Industrial Engineering and Operations Research. We are discussing very important topic of Industrial Engineering and Operations Research, that is called project management. So, in the project management, a powerful quantitative technique is critical path method that helps in the scheduling and monitoring of the project properly. If you have to do some project, it comprises of many activities, and we have to decide in what manner we have to do activities. Some activities can be done in parallel, some can be done only in sequence, and then we can find out that which activities are very critical. That means, if you delay those activities, then whole project will be delayed, whereas there are some non-critical activities, that means you can delay them little bit, that also within the limit, but of course those are non-critical. So, we want to find out critical path. I already told in the last lecture that we can find out the total time for execution of the project by carrying out the forward pass. Then I told about backward pass. Forward pass tells that when that activity can start. So, we go starting from the first activity, we keep moving and we go up to the last activity. In the backward task, in the backward pass, we take the last task and from there we move backward. Suppose we say that this task has to be completed in 25 minutes. So, therefore, before that preceding task has to be completed in how many minutes, and so on. It will go on like that. So, I will specifically discuss now today about the critical path. So, critical path does not mean the path in space, you can say rather path in time. Okay. That means critical path means which activity is important to be done in a specified time. It is not related to spatial distance. Okay. So, here you may get in the exam such type of problem. Suppose example, you have been given various activities A, B, C, D, E, F, G, H, I, J, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 activities are there, and their predecessors have been given. Like activity A does not have any predecessor, but activity B can start only when activity A starts. Activity C can start only when activity A has been done, and activity D does not have any predecessor. That means, it can move independently. Like that we have made this list. Okay. Activity J can start only if E and C both are complete. Even I can start only when E and C are complete, and the activities duration in days have been given. Okay. So, you just see that here, if you take the sum of the activity times, so this is 3 to 5, 3, 8 to 10 to 12, 12, 7, 19, 5, 24, 6, 30, 32, 35. Okay. So, apparently it takes 35 days time, but no, the project time will not be 35 days, it will be much less, because some activities can be done in parallel way. Say for example, activity A has no predecessor and activity D also has no predecessor. So, both the activities can be done simultaneously. So, in exam that question may be like that, draw the activity network diagram, a type of network diagram you can make. And I told in the last lecture that activity on node scheme is there and activity on arrow scheme is there. Two type of schemes are there. You can follow any one of that. You can refer to my previous lecture for drawing the network, and of course, Taha book will deal only activity network diagram, that means activity on arrow. Okay. But you know, some people use activity on node scheme also, where each node indicates one activity. But in activity on arrow, that there are nodes, suppose node 1 and another node may be 2, and I may make that this arrow. So, this arrow is telling the activity and nodes are just telling the events. Okay. So, we have to draw the activity network diagram, you have to gain confidence in that, then determine the critical path, and all activities which are in critical path, they are called critical activities. So, once you know the critical path, you can know the critical activities also, and then find the total project's duration. As I told that most likely the project duration is of course less than 35. Okay. That has to be found. So, now let us say I am just that problem I am just keeping aside, I am not doing to solve that this one, but I can start that activity on arrow. So, activity on arrow in that model, suppose there are activities, suppose activity A takes 2 days, B takes 3 days, C takes 4 days, D 4 this one, and E takes this days. So, I have made this type of diagram. You can say that activity A is called 1 2, activity 2 is basically 2 3, activity 5 is basically 4 5, and the durations have been shown that A bracket 2. So, these are the this one. So, here this diagram is telling me what? This diagram is telling me that activity 2, that means activity B can start only when A is complete, and activity C can start when A is complete. So, you see B and C can be done in parallel also, it is not in series. Okay. Then after B is complete, then you can do D, and after C is complete, then you can do E. So, this is how that it is moving. And now what happens that how do we say, suppose durations have been given, how do we carry out the forward pass? So, in the forward pass I can set that, I can set activity E0, that means earliest starting time of that event. So, set E0, E is equal to 0. As per Taha book, sometimes we make some square type of thing, there we can quickly put 0, and then here it takes 2 days. Okay. 2 days or 2 weeks, whatever is that thing. So, therefore, what you can do that here you write 2. Okay. That is why event 2. So, event 2 occurs at 2, that E2 is written 2, and we make here now 2 and this 3. So, naturally it will take 5, 2, suppose 2 days this, 3 days this, so 5, and 5 plus 5, this is 10, but we have to see other path also. So, here this is 2 and this takes 4 days. So, it already becomes event 4 can start only at 6. Okay. Now, 6 plus 5 is 11, but 5 plus 5 2 is only 7, but you have to take the maximum one. So, that means this is, it will be 6 5 11. Okay. You see from the other path, so 6, this is 11. Okay. So, this will be 11. Okay. So, it is, let me just write 11 properly, this is 11. 11. Okay. So, this is fifth node is at this one. You see that if I would not have done carefully, I have been adding 2 plus 3 5, that means event 3 occurs at 5 days, then I could have said 5 plus 2, because D takes only 2 days, 5 plus 2 would have been 7, but here other path is giving me 11. So, at that you have to see that particular that node 5, you have to see that here 2 arrows are entering that node 5, therefore, you have to check both these sides. Okay. That means, this side, if there would have been third arrow, then that also has to be checked. So, in this case 11. So, naturally the total project duration, if you have done up to this, that means you have found that what is the total project duration, that is 11. Okay. You see that total, okay, this is not that problem, but you can find out that total activity duration is how much, 2 plus 3 5 plus 2 7, 7 4 11, 11 5 16, that means 16 days activities are there if you sum them together blindly, but here it took 11 days. Okay. That is a forward pass. Now, what about the backward pass? Now, set L5, okay, they have written L5 here, that L the latest, that means they indicated by L5, but I am putting that as per Taha book, they make a triangle and they say 11. Okay, that means this activity event has to finish latest by 11 days. Okay, then only the project duration can be 11. Now what we do that here, you go backward. So you see that 11 days this, but this E activity takes 5 days. So 11 minus 5 is 6. So that means this event at node 4 should occur at 6. So that's why this is 6. And then what we have to do that here, 2 minus this one 6 minus 4, that means 2. Okay, this is 2, and 2 minus 2, 0. Okay, that is the thing. So we got 0 and this is. Now what happens other path, this is 11, but this activity takes only 2 days. So 11 minus 2 is basically 9. Okay, that means this can finish, event 3 can finish latest by 9 days. Then what happens that 9, now what happens 9 minus 3 is 6, but 2 has got 2 things emanating, 2 arrows are coming out of that. So you have to see this path also. So from one path it is 2, but from other side you can say that latest it can start 9 minus 2 at 7 days. But this fellow says that lower path that no, this event has to start latest by 2. So you have to listen to minimum one in this case in backward pass, not the maximum one. So you have to say this is 2, and then 2 minus 2 is 0. So therefore this is 2 only and this is 0 only, and like that. Okay. So you have to see, in fact I wrote this one, but I could have stopped here. I would have seen that when I did 6 minus 4, suddenly I wrote 2, but I could have paid attention to that also anyway. Luckily it is always greater, because suppose this path would have given 1, then we would have to write this one. So we do this type of diagram, okay, as per Taha book convention. Otherwise in other book it is written like L1 means indicates backward pass and E1 means forward pass. Okay, here that rectangular or square indicates forward pass and triangle indicates backward pass. Now which path is critical? You can see that, you know that we cannot afford any delay in this path. Which path? That here 11, here there is a some leeway, that because it is 9 and this is 3, but suppose it is complete at 2. Okay, at 2 days you have completed, so 2 plus 3 is 5 only, but you can, but here you have 9. Okay, so that means there is a some freedom there, but here in critical path latest time and earliest time will be same. So here if you see that condition, whether E is a critical activity, yes, because 11 it has to finish at 11, earliest and latest, this is both are same. This is 6 and 6 plus 5 is this one 11. So therefore E is critical. Similarly C 6 and this is 2, this is also very critical. C is critical. 2 is also critical because 2 0 and it takes 2 time. Therefore this is critical path. So what is critical path? I am indicating this path is critical. Okay, so that means ACE is a critical path. And BD, is B critical? No, not critical, because 9 and 5. Okay, so both are not matching here. 2 is matching, but 9 and 5. Here 9 and 5. So this is 3 is also not critical. Okay, so this is how that we do forward and backward pass, and then we do that type of thing. So same thing is stated here again. Forward pass E1 is equal to 0. Here we have written not following the Taha convention. Here we are writing E1 etc. But you can check that same, and therefore this is a E5 is equal to 11. Okay. Now here it is highlighted that when we wrote E1 is equal to 0, E2 is equal to E1 plus time of A, that is 0 plus 2 is 2. E3 is equal to E2 plus time of B, 2 plus 3 is equal to 5. Okay. I am explaining this way also, so that if you are writing programming, in that case it will help that. So, some in the form of equation. Otherwise, when we do hand calculation, then it becomes very automatic, as you have seen that I have been easily writing that thing. So, here E5 is equal to E3 plus TD, that and this came 5 plus 2 7. But I have another path also here, C, E4 is equal to E2 plus TC. So, 2 plus 4 is equal to 6, and here E5 comes out to be E4 plus TE, 6 plus 5 is equal to 11. So, I get two values for event E5, but out of that whichever is the longest one, that means 11. So, this becomes true and this becomes false. So, therefore, E5 will be maximum of E3 plus TD comma E4 plus TE, like that it will go. Okay. And in the backward pass, now we will start from backward way. So, we will first give that L5 is equal to E5, that is 11. This will always be written because the last event is 5, and then you see backward, you keep subtracting. L4 is L5 minus TE. So, 11 minus 5 is 6, and here what happens that 3, event 3. So, event 3, L3 is equal to L5 minus TD, 11 minus 2 is 9. So, you have come up to that, but then when you go to event 2, you see there are two paths. So, you have to say that one value of L2 will be L3 minus TB, that is 9 minus 3 is equal to 6. Another value will be L2 is equal to L4 minus T6 TC, L4 minus TC, that means this time it will be L4 minus TC. So, it will be basically 6 minus 4 is equal to 2. So, therefore, you have got two latest occurrence time of event 2. There are two values. One says that 6 latest it can occur at 6 day, other fellow says no, it can occur latest 2 days. So, naturally the minimum is 2, okay, because if you make latest occurrence as 2, then the other guy also will be satisfied, because it says okay fine 6 days, because he said that latest means maximum delay, how much we can expect. So, this is 6. So, that is why that this will be class and L2 will be 2. So, therefore, this is okay, and then of course, so out of this will be 2 and 2 minus 2. Now, L1 is L2 minus TA. So, 2 minus 2 is equal to 0. So, that is why that this becomes this one. So, this is the backward pass. Okay. I have not shown in the same diagram both the things, but you can compare that forward pass, these are the times, backward pass, these are the times. You can put that thing. So, critical path is shown in red color. I have already shown in the beginning that ACE. Okay. So, ACE, this is ACE, and the critical path of the project is basically we say ACE event, but A is basically 1 2. So, we can say 1 2 4 5. Okay. So, and critical activities are A 2 CE. See that this is the critical path. Okay. This is shown by red color already. So, we can say we can either write critical path in terms of the activities ACE, or we can also tell in terms of the events 1 2 and then 4 5, 1 2 4 and 5. So, this is 1 2 4 5. So, total project duration is equal to sum of durations of critical activities, that also is there, 2 plus 4 6 plus 5 11. So, therefore, this is a critical path. But here other side 2 plus 3 5, 5 plus 2 7, that comes 7 only. So, therefore, that is non-critical path. Okay. In critical path you are going up to this one. So, therefore, total project duration has come 11 days. Okay. Now, let me just explain it in a very formal way. An activity Ij, that means we are following activity on arrow style. So, Ij means ith node, and this is another ending time of activity j node. So, this is I and this is j, and suppose activity is like this. So, Ij, it will be critical if it satisfies these 3 conditions. Okay. What is the 3 conditions? Latest occurrence time of event I is equal to earliest occurrence time of event I. That means both latest and event is same, and then latest occurrence time of event j is equal to earliest occurrence time of event j. So, that means earliest and latest will be same. Okay. That means this is like that. Okay. And earliest occurrence time of event j minus earliest occurrence time of event I is equal to activity duration, and that can also be written as latest occurrence time of event j minus latest occurrence time of event I. Okay. So, that means it is equal to this way. Okay. So, when an activity is plus duration is equal to LF, or equivalently when it is a float, that means suppose LF minus EF, LF latest finish time minus earliest finish time. Okay. Suppose it is equal to 0, then it is a critical activity. Okay. That means if you are following activity on node style, then it will be like that type of thing. You can say LF minus EF is equal to 0, earliest finish time, and we know that earliest start plus duration is equal to earliest finish also. Anyway, earliest finish also. Okay. Earliest start plus earliest duration is equal to earliest finish also. ES plus duration is equal to EF. So, what happens that if you have LF minus EF is equal to 0, then it is a critical activity. So, therefore, I have said that suppose this equal to LF, that becomes the condition for critical activity. Okay. So, it is just algebra. So, you can say that sometimes we can say this also, ES plus duration means earliest start plus duration is equal to latest finish. Okay. That becomes this one, that critical activity. Okay. That is what this one, and we know that LF is equal to EF also. So, that type of thing. So, ES plus duration is equal to LF if that condition, because ES plus duration is equal to EF, that is always there. Okay. Earliest start plus duration, that means it is earliest finish. Okay. So, there we define earliest start, earliest finish, latest start, latest finish. Okay. In fact, LF will be latest start, LS plus duration. Okay. LS plus duration. So, you can say that it is LS plus duration. Okay. So, if duration comes both sides, so that means it gives automatically ES is equal to LS. That means earliest start and latest start should also be same. Earliest finish and latest finish should also be same. So, that means this is also there. Okay. So, you know, these are the relations in a this one. Some of them may be redundant, but you know this is the thing. So, let us try to solve this problem, that suppose there are activities and we have got predecessors and we have got durations in days. A is equal to this one nil, and predecessor is nil, and we have got this one, and we want to find out network diagram. So, how can I draw the network diagram? Sometimes you have to draw 1 or 2 times, and then you have to erase and make that thing, but let us see that. Suppose activity A. So, this is starting is 0 and it takes 3 days, then you go to 2. Okay. And then after that, after A can be done, then you can do B. So, therefore, you make that B like this. And then similarly, D is also, C can be done after A. So, therefore, C can be done after A. Okay. That means A has been done, you have done here, but D does not have any predecessor. Okay. D does not have any predecessor. So, D can start starting from node 1, that D, and then after that E is that D. So, D is completed, then only you can do E. So, E will go this way. but both B and E will be there, then only F can do that. So, both B and E should join in the same node, okay, that is 5, and then you can do that F, and this is how that you have reached at that point. Then what it says that both B and E are done, then you can do G. So, both B and D, so G activity is parallel like this 7, and then what you can do that here. Okay, let me just go to that one. Okay, yeah, this is about this one. Okay, yeah, so G is done, F is done. Then what happens about J? J can be done when E and C are complete, and I can be done when E and C are complete. So, it is like this. J can be done when E and C are complete. Okay. So, E is this activity, C is this activity. So, C I have done this way, that is J can be done only after this one C and E both. So, there was no path here, that is why I made a dummy activity. I ensured that this dummy activity should also be finished, but dummy activity itself has a constraint that E should be complete. So, that is why I should satisfy. So, you see that we may have to make dummy activities with 0 time and with dotted 1. So, then only I can make that J. And if I say that H, as far H is concerned, F and G is the requisite. Okay. So, F has been made that this one, and G is this one. So, F is going here and H. So, G is the prerequisite. Okay. So, this is H, F, okay, F and J. Okay. That means H activity needs that F and J both should be complete. Okay. So, this is F and this is J. Okay. So, both are complete. Here they are meeting at this event node number 6, then only H is starting. Okay. So, this is what that H, and then what happens that here. Okay. Yeah, this is G, this is this one, G is there. Okay, fine. So, it is J is equal to E and C. Okay. J can be completed if E and C are complete, like that. So, we made that network diagram. After making that, you counter check, because sometimes there may be mistake also. So, it is better to counter check also and see that whether whatever has been given here in the list, whether that thing is getting satisfied or not. So, observe how dummy activity is included in the network diagram, that is important. Now, forward pass. Okay. Now, you can do the forward pass type of thing, and you can do backward pass. It is written in a very systematic way. Suppose event 1 is starting, earliest time is 0, then earliest time of event 2 is E1 plus TA, 0 plus 3, 3, here 0 plus this one is this one. But let me do that as I will do in the exam, little bit faster way. So, let me just do that. This is the thing that here I will make that rectangular type of thing, because forward pass I make rectangular and I put here 0, and then here I will come to 2 and I will make it 0 plus a 3. So, this is I will make 3, then I will go to that 4, and but 4 has got 2 events. So, therefore, I will not go here first, I will go here 0 plus this one 2. So, that means I will make it 2, okay, 2, and then 2 plus 2 means this I will make that this is the thing, but there is a 5. So, there is a 3 plus 2 is gives 5, and 2 plus 2 gives 4. So, therefore, I write here 5, maximum one at note 5, 5, and then 5 plus dummy activity 0, but this is a 3 plus 3 is 6. So, therefore, I will make it here 6, 6, and then what I will do that after 5 I can naturally go to that 7 activity in event 7. So, we will say 5 plus 5 is equal to 10, but there is another path also, this is I2. So, 4, 6 plus 2 is 8, no, this is, suppose we have got 6 and plus it is T in this one, and we are getting one path is TG, but other site is also coming from here. There is a This also path is there 6 plus 2, in fact I would have written here 3, this third thing also here. So, here that first we let us make it here that 6 plus 3 is 9, but 5 plus this one 7. So, 7 plus 5 is 12. So, this will be naturally 12, and then 12 plus 6 is 18. So, therefore, I will write it 18 here. So, that is what 18. So, this way I have finished the forward pass. So, 18. So, you can see that my maximum project duration came out to be 18. That everything is culminating here, from 7 is nothing going out. Okay. So, that means 18. Okay. That is the forward pass. We can do here itself that backward pass also. We can 18, triangle 18, and 18. Now, you go to the event 6. Okay. So, this is 18 and this is 12. Okay. So, this will give you basically 6. Okay. Sorry, duration is basically 6. So, 18 minus 6 is 12. Okay. This will get 12. And now, from here even I can go here that from 7 we go to event after 6 I can go to node 5. At 5 I have 2 paths. Okay. They are means 2 arrows which are emanating. One is that 5. So, here 18 minus 5 is equal to 13, and here 12 minus 7 is equal to 5. Okay. So, you have to take the smallest one and you have to say that 5. Okay. So, that means event 5. So, this is basically 5. Okay. And then 5 minus this is actually 2 and this was okay. So, this is 5, and 5 minus 2 is basically you can say 3. Okay. So, we can say this can start basically 3. Up to this we have gone, but we have to see the other paths also. So, you have to see at node number 4 what happens. Node number 4, that one path is 12 minus 3, that becomes how much, that 12 minus 3 becomes 9. Okay. So, I could have put here 9, but we have to see any other path also. This is 18 minus 2. Okay. From here to here 18 minus 2 is 16, and this latest one. So, 2 things are emanating. So, you have to see that basically 9. Okay. That means like that. And similarly, you have to say 9 minus 3, one root is 6, but other root is actually 5 minus 2. So, 3. So, you have to say 3, and then 3 minus 3 is 0. Although from this side if you do that, 3 minus duration of 2 is basically 1, but you have to say the minimum time in the backward pass. So, this is 0. So, you have gone like that. So, let me just see that. Okay, but backward pass, let me explain in case I would have done any mistake in this one. So, these things are explained here separately, that activity L1 is starting like this, and this is equal to 0. So, here we will we will start from last node L7 is equal to 18, then L6 we come easily because from 6 only one arrow is coming out. So, we have to pay attention to that, but in the 5 there are 3 arrows coming out. So, we have to see all those paths. So, in fact, in 4 there are 2 arrows are coming out. So, we have to see both the paths. 12 minus L6 is 12. So, 12 minus 3, that means 9, and another path is that 18 minus 2 is 6. So, you have to take the 9 one, and here in this one, in this activity, when you come to the node 5, then you have to say that L2 these arrows are coming out. So, L7 minus TG, L7 minus TG, okay, that you have to see 18 minus 5 is equal to 13, and also you have to see 12 minus 7 is equal to 5, okay, because L6 is 12 and this duration is 7, and also this is also going out 4th. 4th is took 9, but 9 minus 0 is equal to 9. So, I could have say written that 9 also, but in among them the least is basically 5. Okay. Then 5 minus 5 this one and this everything. So, we have seen that this condition and we have seen the forward. So, naturally the critical path is A3, A, B and this F and H, because in this condition at we can see here also A, because 0 0 these things are matching, triangle number and rectangular number is matching 3 3 and this is 5 5 and this is 12 12 and 18 18. So, the path will be like that. Okay. So, this will be critical path we have. So, critical path is shown in red color. So, critical path have the project is 1 2 5 6 7 and critical activities are this one, and minimum time of project completion is the sum of duration of critical activities, that is 3 plus 2 plus 7 plus 6 is equal to 18, that is coming that way. So, it is this one, and now we can actually do that, find the earliest start, earliest finish, latest start, latest finished for each activity. This is the problem. Okay. Suppose it is given, then we can follow activity on node style also. In the activity on node, this will be now, this is a start that circle, but this is activity A. Activity A, its duration is shown here 3 and this is the earliest start and this is earliest finish. So, like that we do, ES is equal to 0, EF is equal to 0 plus TA. Otherwise, other procedure is exactly same. Somehow Taha book has used only activity on arrow style and I also like that approach. So, therefore, you can follow that, but activity on node approach is also shown here. This is activity, this is duration of activity. In the forward pass, you will fill up ES and EF. In the backward pass, you will fill up LS and LF. Okay. So, you are doing that activity D and activity F, activity this one. Okay. You can pause the video, you can understand that how it is done, it is very clear, diagrams are self-explanatory. You can find out, suppose for activity D means maximum of EF of A and EF of B is equal to this one, na? Maximum of 3 2 like that. Okay. So, it will be finished at 3 and this will be finished at 2 days, therefore, maximum is this one. So, it can start at 3 only, because maximum of that, because B will finish in 2 days, A will finish in 3 days. So, naturally that I can start only at 3 days. So, you know, you see the arrows which are entering that circle, among them whose you know that finish time, earliest finish time is more, that value will be taken. So, this is 3 and 3 plus 2 is 5. So, this is obvious. So, this is this one, and similarly then you can have in this problem that it is 19, and similarly you can do the backward cast calculation, backward pass calculation. There also you go in the backward way, you start from 19 and 19 minus 2 is 17, but when you come here this is 17, see this is finished 17. So, this is 17, 17 minus 11 is 16, this is 17 minus 3 is 14 and like that. But when you come to this one, then you see 2 arrows are going. So, you have to see check both the paths. Okay, that you can say 11, this is basically 7 and this is, suppose its earliest start is latest start is 14, its latest start is 7. So, therefore, here latest finish should be 7 only. Okay, minimum of that. So, therefore, this is also done and this is what you can do that, and you can find out for each activity. This is the thing. So, this much for today, and then I will tell the other things in the next lecture. Thank you very much.